Hi Terry, thanks for sending us in your math problem here regarding calculus and setting up a related rates problem. The first thing we want to know is that they're asking us for the rate of the line of sight distance between the plane and the statue. So if here's our statue here, I didn't really jot it down, but I'll kind of put a picture here. They're talking about this distance here and the rate that it's changing at. So in other words, they're asking for, I called it W here, they're asking for dw dt. I've labeled this guy X because anything that's changing in the diagram must be labeled a variable. Okay, now see how this is 2. Notice I didn't call that a variable just because it's constant. So this is always 2 throughout the whole problem as the airplane travels here from left to right. Okay, and then they also give us dx dt, which is 4.5, because the airplane's always traveling to the right at 4.5 kilometers per minute. Okay, the first thing we want to do is change this 20 seconds. We want to change that to minutes. Okay, so we're going to just do a little train track here. And 60 seconds to 1 minute. Okay, I'll extend that guy. Okay, so basically we get 1/3 minutes. Okay, probably could have done that in our heads, but we'll write it down. So we have 1/3 minutes here. Next, what we want to do is write an equation out relating these variables. Okay, so as you can see, it's a right triangle, so we can do x squared plus 2 squared equals w squared. So that's our equation relating all these variables. And now we're going to implicitly differentiate with respect to time. Okay, so we take the derivative, it'll be 2x, and then dx dt, okay, which we know, plus 0 equals, if we take the derivative of 4, it's 0, and then equals 2w, and then dw dt. All right, great. So now we have, actually, let's go up to our problem here. Do we know x? So when the altitude's 2, the plane is, so at 20 seconds, we need to figure out what x is. Okay. So if we look here, since the plane is traveling at 4.5 kilometers per minute, if we multiply that, I'm going to call that 9/2 instead of 4.5 kilometers per minute. And if we multiply that by 1/3 minute, because that's how long it traveled after it hit the Statue of Liberty, then that's going to give us, those cancel out, we get a 3/2, so we'll say 1.5 kilometers, running out of space there. Okay, so that's how far it traveled from here to here. Okay, so now we know, I'm going to draw that same triangle here, that this is 1.5, and then this guy is 2, and then w. Okay, so if we set up 1.5 squared plus 2 squared equals w squared, and we solve for w, I'm going to save you the time here, we'll get w equals 2.5. Okay, so now we have all the necessary ingredients to plug in here because we're trying to find dw dt. So we plug in 2, and then x is 1.5, we found that. And then dx dt is 4.5, I'll just change that to 9/2. And then we have 2 over here, and then w, which we found out to be 2.5, and then dw dt, which is what we're trying to solve for. Okay, so I've done this work already, so if we solve for dw dt, we are going to get 2.7. So that's the rate of change from the airplane to the statue of this distance here when time equals 20 seconds. All right, thank you so much for sending in your problem today, Terry. Thanks for using SnapMath, and have a good night.